Hi guys, welcome to Pagapaiva channel. In our last video, we have explained you how to minimize the transportation cost using optimization model. In that we have taken a business case which has two factories of fixed capacities which are of equal capacities, and they have their distribution in such a way to regional warehouse, then to divisional warehouse, then to their local distributors. The first scenario in last video, what we have shown is the transportation from factory to their regional warehouse. They have 5 different regional warehouses across the country. So in that we have used the Excel solver to find out the optimized or minimum cost considering the available constraints. So if you have not watched that video, the link is available in description. Please go and watch it. Now, in this video, what we are going to talk about is we have moved the biscuit boxes to regional warehouse. Now we have to move these boxes to divisional warehouses. So now we are going to calculate the transportation cost for movement from regional to divisional warehouse. And obviously our objective is to minimize the cost. So now here we have the divisional warehouses demand. So the company has 14 different warehouses across India, of which 4 warehouses is same as the regional warehouse. So the regional warehouse will act as the divisional warehouses as well. So 10 different divisional warehouses and 4 regional cum divisional warehouses, totally 14 divisional warehouses. The total demand is around 4,25,600 boxes, which is less than the regional warehouse demand. So there will not be any problem. So the regional warehouse can supply these boxes without any difference or loss of sale could arise. So now we have the divisional warehouses distance, divisional warehouses to regional warehouses at each location. What is the distance in kilometers is available for this will be used for calculating the transportation cost, because 9 rupees per vehicle per kilometer is applicable. So we have already calculated the transportation cost in our last video, which was around 54 lakhs. So we are going to maintain the same thing. So the number of vehicles and everything, we are going to keep it fixed in this scenario. What we are going to calculate is actually the number of vehicles required for movement from regional to divisional warehouses. This yellow highlighted area will give us the output. And here what we are going to calculate is simple. What we are going to calculate is the number of boxes. So each vehicle could take around 500 boxes, which is fixed, and number of vehicles. So if the vehicle is 1, you can see 500 is automatically updated. So now I have considered 1 vehicle from each regional warehouses to divisional warehouses, due to which, since 500 number of boxes can be transported from each vehicle, so automatically the value got changed. And then we can easily calculate the transportation cost. Transportation cost is nothing but your number of vehicle, so which you will be calculating here in this cell. Then the kilometers, already I have shown you this table having the distances in kilometers, then ₹9. So based on which the transportation cost is calculated. Sum of all this transportation cost will give this regional warehouse to divisional warehouse transportation cost. So likewise, we have built the model And now we will talk about the constraints. The first constraint is nothing but like the whatever the inbound to each warehouse or supply to each warehouse should be greater than or equal to their demand. Same condition is applicable here also. So supply to divisional warehouses should be greater than equal to their respective demand. The next constraint is whatever inverted at regional warehouses, that much only can be dispatched. So the inverts already we have calculated in our last problem. So this is our inbound quantity. To Chennai, it is 95,000, Pune 87,500. Likewise, so those values are mentioned here, which is the inbound. So you can dispatch up to 95,000 boxes only at Chennai. So beyond that, you have to depend on other warehouses. So this condition is there. So the outbound should be less than or equal to inbound at regional warehouses. Second, then the third condition is very much easy. This values can't be negative, sorry, as well as decimal. So it has to be an integer. So now we will build the model. Before that, I'll show you one thing, which is the total transportation cost, which is the sum of factory to regional warehouses transportation cost plus regional warehouse to divisional warehouse transportation cost. So our objective is to minimize this. Going to solver. My objective is this. I'm going to minimize it. So I have selected my objective. Then what we are going to do is we are going to change the yellow highlighted cell. So by changing this yellow highlighted cell, because when the number of vehicle changes, automatically the number of boxes as well as the other dependent things like transportation cost, everything depends on this number of vehicles. Then we will add the constraint. The first constraint, we will add these values or integer. The second constraint is what we have discussed is about the supply to divisional warehouse should be greater than or equal to their demand. The next thing is this outbound should be less than or equal to inbound. So three constraints we have added. Simplex LP, make sure this box is ticked. And once you click solve, Excel will take some few minutes because you can see it is working on the possible solution to come up with the answer which can support us. So now Excel has given an answer which is 83,75,000. So here actually the earlier value is already fixed, so there is no change over here. Actually, Excel has worked out this value only. It worked out in minimizing this value. So 83,75,000 is the transportation cost. Then similarly, now we are going to calculate the margin, which we used to do, selling price, which is going nothing but the total supply to divisional warehouses multiplied by 50. 50 is the number of packs, number of biscuit packets per box, multiplied by 10 rupees is each biscuit packet cost. So total selling price is this much. Then manufacturing cost, you can take it from past videos. For two factories, so we are multiplying it by 2. Then the total cost would be simple, the transportation cost and manufacturing cost. Now the profit is around 16 crore. The margin is around 308%. So now you have calculated the total transportation cost for moving up to divisional warehouses. But if I ask you whether this is the best solution, it is obviously not. Actually, I can tell you that we can able to reduce it further. There is something which we have to add in this model to reduce this transportation cost. But we will stop this video here. We will show you this, how we can reduce this transportation cost further in our next video. You can see, which is something around 2.5 lakhs, 2.55 lakhs is the reduction which you can able to achieve by making some changes in the model, which we will show you in our next video. If you can able to find it out, please mention in the comment section. We will also understand if you have some ideas, you can able to share it. If you have any queries, please put it in comment section. Please share with your friends, like this video, subscribe our channel. Thanks for watching. Bye-bye.